Okay, so let's begin with problem number 20. And what is the hydrogen ion concentration if 12.3 grams of HCN is dissolved in 125 milliliters of water and is 2.34% ionized? So HCN is a weak acid. The concentration of the HCN in the water will not equal the concentration of the H3O+. So we have to do that calculation first. So we figure out, first of all, molarity of HCN and then the molarity of H3O+. So let's switch over to write this. So in this case, we have 12.3 grams of HCN in our beaker here that has 0.125 liters of water. So 12.3 grams must become moles of HCN, and then that moles of HCN divided by 0.125 liters will give us moles, well, I'm sorry, it gives us the molarity of HCN. But in this particular problem, let's double check this. We know it's only 2.34% ionized, so we'll take that molarity, multiply it by 0.0234. Remember, that's 2.34% divided by 100%. And that will tell us what the concentration of H3O+ is. How many of those H pluses come off of the HCN? And that's our concentration. So first step, grams HCN has to become moles of HCN. And then that mole, that number of moles there, divided by 0.125 is simply going to be moles per liter, which is molarity. And then we multiply that by the percent that's ionized to get the concentration of H3O+. So those are the steps, grams to moles, and then we calculate the molarity, which is moles HCN over liters of the solution, and we multiply that by let's just multiply it by 2.34% divided by 100%. And that gives us H plus concentration in molarity. That's what we want. Now in problem number 21, we are asked which one of the following compounds would exhibit the strongest London forces. Now I want you to remember about London dispersion forces. These are just the ability of the electrons in atom or molecule to be polarized. And what we learned is that as mass increases in a nonpolar molecule, really what's happening is the number of electrons are increasing. And so the molecule with the most mass, the highest mass, has the most electrons. Therefore, it's the most polarizable. And in this case, that's going to be the one that has the most carbons. Now for question number 22, it's a simple concentration calculation. We're given a mass of, in this case, sodium nitrate, NaNO3, is present in 555 milliliters of water. So the calculation is straightforward. We are given we have to go back and check here. What do we have? We have 3.358 grams. So 0.358 grams in this case of NaNO3. This must become moles of NaNO3. And once we have that, the definition of molarity is moles per liter. So we divide that by the number of liters. In this case, that was 0.555 liters. And that's all there is to it to calculate molarity. We convert grams into moles